All right, so this is our second video for section 4.6 over properties of logarithms. And in this video, we're focusing on two very important equality properties of logarithms, okay? And they're going to lead us to a very, very useful formula known as the change of base formula, okay? So the properties are listed in red here. And the first one there, property 6, it says if m is equal to n, then log base a of m is equal to log base a of n. All right, now that is extremely important. What that tells us is that I can essentially treat a logarithm like an operation on an equation. If I'm working with an equation, I'm allowed to take the logarithm of both sides of the equation, okay? And property 7, it just works in the reverse order. It says if I have two logarithms that are equal to each other, provided they have the same base, then that means their arguments are equal to each other. Okay? So we're going to see these properties at play here. I'd like to approximate log base 3 of 12 to 4 decimal places by writing it in terms of the common logarithm. Okay? So think of it like this. What I'm trying to do is see what log base 3 of 12 is equal to. Okay. Now you can kind of reason this out. You're saying that 3 to what power equals 12. That means this is going to have a value somewhere between 2 and 3 because I know that 3 squared equals 9 and I know that 3 cubed equals 27. Well, 12 is obviously in between 9 and 27, okay? And what I'm going to do here is I'm going to put this into its exponential form, okay? 3 to the power of x is equal to 12. And then when it says approximate this by writing it in terms of the common logarithm, okay, what that means is it wants me to use this property right here. I have two expressions that are equal to each other, so that property states that I can take the common logarithm of both sides. Okay? Now, how does that help me? It almost looks like I'm making this more complex, okay? Well, I can use the power property of logarithms now to bring x in front here. That's going to lead me to x times common log of 3 is equal to the common log of 12, okay? And what you have to understand is that the common log of 3 is a numerical value, and so is the common log of 12. So I can solve for x here by dividing both sides by the common log of 3. Those will wipe out, and I will end up with x equaling the common log of 12 divided by the common log of 3. And the nice thing about this is my calculator is programmed for common logarithms. Okay, I can approximate this now using the calculator. So on your graphing calculator, here's your log button. So if I do log of 12 divided by log of 3, I end up with approximately 2.2619 for the value of this logarithm. Okay, and I can check this very easily. We're saying 3 raised to this power of 2.2619 is exactly 12. Okay. Now let's make try to make the same approximation writing in terms of the natural logarithm. Okay. So we're basically doing the same process. We're just using the natural log instead of the common log. Okay. So I will start the same way with the exponent of the exponential form, 3 to the power of x equals 12, and now I'm just going to use the natural log of x on both sides. That allows me to apply a power property, bring the x down in front here, multiplying the natural log of 3, and then I can divide both sides by the natural log of 3. Those wipe out. X can be thought of as the natural log of 12 divided by the natural log of 3. And reason I chose natural log here is because it is also programmed on the calculator. And let's see if we end up with the same value as we did up above. Right here's your natural log button, natural log of 12 divided by natural log of 3. Gives you that exact same value as we got up here. Okay. All right, so what I'm getting at here is that this property number 6 is very beneficial in that it leads us to being able to evaluate a logarithm no matter what its base by using our calculator. And what it takes us to is the change of base formula. Okay. So the change of base formula says if A is not equal to 1, B is not equal to 1, and M are positive real numbers, then log base A of M can be thought as this. Log base B of M over log base B of A. Right? Notice this formula is exactly what we ended up applying in the end to approximate log base 3 of 12 here. Okay, I did it one of two ways. I changed log base 3 of 12 to common log of 12 divided by common log of 3, and I also changed it to natural log of 12 divided by natural log of 3. Basically, we're saying that this base can be any base you want it to be, as long as it's not equal to 1. And we just typically make that base either 10 or e, since our calculators are programmed to evaluate common logs and natural logs. Okay, so not sure if you really realize it right now, but this is a huge formula because it now allows you to evaluate any logarithm on your calculator, no matter what its base. Okay, let's approximate log base 5 of 89 to 4 decimal places. Okay, so kind of reason this out. 5 to what power equals 89? This answer is going to have to be somewhere between 2 and 3, because 5 squared is 25, 5 cubed is 125, and 89 falls in between those, right? So by this change of base formula, I could rewrite this as the following. I could do this as common log of 89 divided by the common log of 5, or I could do natural log of 89 divided by natural log of 5. Okay. Punch into my calculator. I'll just do the natural log version. And there we have it, 2.7889. And of course, we can check that, right? 5 raised to the power equals 89.